Hi, for this video what we're going to do is we're going to be graphing absolute value equations using translations. A translation is a left, right, or up, down movement of your parent function. So for this one what we have is we have a vertical translation if the addition or subtraction is on the outside of the absolute value. And it's going to be a horizontal translation if it's on the inside. The way the vertical translation works is that it's the same as the sign of the value that's being added. So if it's plus, you go up. If it's minus, you go down. The inside is a little bit different because it's the value that makes it 0 inside, so you always go opposite because it's x minus h. So if it's a plus h inside, that means it's going to shift to the left, and if it's a minus h, you would shift to the right. So for the example that I have out here, the first thing that we want to do is remember, what does our parent function look like? So our parent function, remember, is f of x equals the absolute value of x. And so for this, my parent function always goes through the point 0, 0 because the absolute value is 0 is 0. The absolute value of 1 is 1, the absolute value of 2 is 2, and then it continues on forever and ever in that direction. So it continues this way. So this is my parent function. And then the absolute value of -1, remember it's our distance from 0. So the absolute value, or the distance from 0 that -1 is -1. And we would have -2, and it would continue forever and ever in this way. So with a translation, what you're going to do is you're going to take each of these points that we have here, and we're going to shift them by the amount that it says in our equation. So for this one on the inside, remember we always go the opposite. So this tells us to go left 2, and this one tells us to go up 3. The other shape of it, it's not going to change. It's still going to go up 1 over 1 and up 1 back 1 for the other side. So if we start at our vertex, it tells us to take and shift it over 2, so right 2, and then turn and move it up 3, 1, 2, 3. From there, we can use the same pattern, or we can go to the next point and do the same thing. So if I take this point, I'm going to shift it over 2 and up 1, 2, 3. Or we could just use the same pattern where it's up 1 over 1, up 1 over 1. And then it's going to continue forever and ever in that direction. So this would be one side of it. Remember that an absolute value always gives us a V-shaped graph. So on the other side, we would just go up. Or if we wanted to take this one and shift it left 2, 1, 2, and then up 3, 1, 2, 3. Or we could have just gone up 1, back 1, because that's the pattern of the left half. So this would be our graph of this equation. So it's always going to be a V-shaped graph. It's always going to go up 1 over 1 to the right and up 1 back 1 to the left. The vertex is what is important, is finding where does it change its, or where does it make its V. So let's look at another example. For this one, remember that we always go the opposite of what's inside. So this tells us that we are going to go right 3. And the reason that it's right 3 is because 3 minus 3 would give us 0 in here. And that's where our shift is going to happen. So this one's going to go right 3 and down 1. So remember, we always start at the origin, and then we would just turn and go right 3, 1, 2, 3, and down 1. And then you have the choice of either moving to the point -1, 1 and going right 3, 1, 2, 3, and down 1, or we can just use the pattern where it's up 1, back 1, up 1, back 1, up 1, back 1. And then for the other side of our V, we could go up 1 over 1, up 1 over 1, up 1 over 1, and so that would form our V-shaped graph. You can always check these points to make sure that they are true. So if I substitute in, let's say this value here, 1, 2, 3, 4, 1, 2, 3, 4, 4 minus 3 would give us 1, and 1 minus 1 is 0. So we can see that that does give us the correct point. As always, thanks for watching. If you have any questions, please let me know.